Hello, welcome to this lecture on Laplace transform, part 12. So in this, we are going to see a differential equation. It's a special form. It's called, we are going to see what is known as an integro differential equation. Integro differential equation. Well, what is an integro differential equation? So it is an equation, simple. It's an equation which has got both an integral and differential derivative form of the same function. So it is an equation which has got both integrals and derivatives of a function. So that is known as integro differential equation. So let us take a simple integro differential equation and try to solve it. So the given equation is this. This is an integral of y tau d tau equal to dy by dt. The initial value is 1. So let us solve this by the usual method. Take Laplace transform on both sides. So first one, left hand side is the integral. So integral Laplace transform is, this is ys by s. See, this is, you may think this is y of t, this is y of tau. This being a definite integral, y of tau d tau is the same as yt dt. So this can be considered as integral 0 to t of yt dt. So the Laplace transform of this is this one. The Laplace transform of y tau dot t tau is ys by s. And the right hand side, the Laplace transform is s into y of s minus y0. So next substitute the initial value is given as 1. So substitute here s into is minus 1. I substitute the initial value which is 1. Then take y of s common, simple self-explanatory. Take y of s common and simplify y of s equal to this. Now you have to take Laplace inverse. What is the Laplace inverse of this? You know, what is the Laplace transform of cos h? Cos hyperbolic function is s by s square minus a square. So we can use this formula here, s by, so this is also same form, s by s square minus 1. Here a is 1. What is the inverse of this? Using this formula, the inverse of this using this formula is cos ht. A is 1 here. So this is the solution. So this is the solution of this equation. It's a simple integral differential equation. So you got, after taking Laplace transform, we got a expression, simple expression, which can be directly applied by using this formula. Using this formula, directly you can write the Laplace inverse Laplace. It is cos ht. I hope you understand. I hope you understood this. Now let me give you another equation as an exercise. So this is also an integral differential equation. You have derivative term, integral term. So dy by dt plus etc. equal to this. The initial value is 0. So try to solve this and find out the answer. I leave it an exercise for you. Anyway, I'll give you the answer of this question at the end of this lecture. I hope you have been following all my lectures and you are finding it useful. And I hope you also understand them. If you have any comments, if you are not able to understand, if you have any questions, you can leave your comments in the comment section below. I also request you to subscribe to this channel, because when you subscribe, you will get notifications of my channels in future. So I'll be publishing more lectures on Laplace transform, process control, gate topics. So when you subscribe, you'll be notified of these lectures, and you will not be missing any lectures. So I request you to subscribe to the channel and also share to your friends and other students. Now coming to the answer of this. So this is the answer for this question. So the answer to this question is given here. So you can practice this and verify this answer. To solve this equation, you can also take you can take help from my previous lectures, part 8 and part 9. So there I have done similar equations, even though they are not integral differential equation, but for finding inverse Laplace, those lectures, part 8 and part 9, will be useful in solving this. So you can refer to those lectures, part 8 and part 9, the links for which I am giving in the description below. So please try to do this and see if you get this answer. Okay. So in this lecture we had used Laplace transform of an integral as well as a derivative, and also Laplace transform of cos h. 1 minute, there is a small mistake here. This must be cos h at. Okay, I missed a here. This must be L of cos h at is s by s square minus a square, and in this case a is 1. A is 1, so s square minus 1, a is 1, so the Laplace inverse Laplace is cos ht. So okay, so practice this question and try to get this answer. We'll see you in my future lectures. Come with more of Laplace transform related topics. See you till then.